I am not going to answer every single question that's in your math packet. However, these are some of the more common issues that have come up in my classes over the last few days. So feel free to jump around within the video and see if I talk about the one that you have a question on. And hopefully all of your questions will be answered and you will have a complete packet to turn in tomorrow. So let's start with the very first one that we see here, putting numbers into scientific notation. And we're going to start with number 14, and that's 156.90. The first thing that you need to do is to move your decimal point, and you want it to be to where there's one non-zero digit, and then everything else is after the decimal point. So we're going to move our decimal 2 spaces. We're moving it to the left, and so our final number 1.5690, and now we put our 10 to the, we put our exponents in, times 10 to the, we moved it 2 spaces, 1, 2, and so our exponent here is to the 2. The next one, number 15, 12,000. With a number like this, you assume a decimal point at the end. We're going to be moving it again to where we have a non-zero digit, and then all the other numbers come after it. So we're actually moving our decimal point 1, 2, 3, 4 spaces. Now when we rewrite that, 1.2, we don't have to write all of these extra zeros because they're not significant figures. So we just stop at 1.2. 1.2 times 10 to the 4th, because we moved it 4 spaces. The next two examples are going the opposite direction. We're moving our decimal point to the right. So I'm not going to rewrite those numbers. They're very, very long. But you can see that we want our decimal to go right in between the 6 and the 5 right here. And so when we do that, we're going to have 6.5 times 10 to the, that's where we count how many spaces, and we went 1, 2, 3, 4, 5. But this time we went to the right, so it's to the negative 5. And then finally, we have units, so we keep our units, kilograms. 6.5 times 10 to the negative 5 kilograms. And we'll do the same thing underneath number 21. Your decimal point is going to go after the first non-zero digit, so right here after this, 4. So we rewrite that 4 point. And all of these numbers after the 4, we still have to add those because they're all significant digits. So 4.00970 times 10 to the, count how many spaces we moved, 1, 2, 3, 4, 10 to the negative 4, because we moved to the right, and it's centimeters. The next part where people were having issues is in the dividing and in the addition subtraction. So the first thing to remember, when you're dividing numbers, you keep your coefficients together, 6.6 over 3.3, and then you work out your exponents. And so it's times 10 to the, we're going to subtract, negative 8 minus a negative 4. And when you actually do that, 6.6 divided by 3.3 gives you 2.0 times 10 to the negative 8 minus a negative 4 is the same as saying negative 8 plus 4, right? Because we change our sign. So that's to the negative 4. We're going to do the same thing down here. Do your coefficients first, and then your powers of 10, or your exponents. And in this case, we have 2.5 over 7.5 times 10 to the 8 minus 2. When we do that, what you end up with is actually 0.33 when you do this part, times 10 to the 6. But you can't leave it that way, because this is not in scientific notation. You have to fix it. I'll make it a little bit smaller so I have some more space. You have to take your decimal point from here and move it over to the right by 1 space. So that gives you 3.3 times 10 to the, and we've moved our decimal point to the right, which means that our exponent goes down, so it's 10 to the 5th. For 29 and 31, adding and subtracting, remember that you change your exponent first so that they match. The first and second numbers have to match. Then you can add your coefficients and go from there. So in this case, we have a 10 to the negative 7 and a 10 to the negative 8. I'm going to change the second number and make both of our exponents negative 7s. So we'll have 1.56 times 10 to the negative 7, plus, and we want this number to be a higher number. We want it to go up from negative 8 to negative 7, and so we take our decimal point and move it to the left. So it's plus 0.243 times 10 to the negative 7. Now, our exponents are the same. So all we have to do in this case is add our two numbers, 1.56 plus 0.243. When you add that together, you get 1.803. We leave our exponent the same, times 10 to the negative 7. If you had changed the first number, if you had changed the decimal place on the first number, you would have ended up with 18.03, in which case you would have to fix your exponent. So this is going to be your final answer, no matter which one you moved. We'll do the same thing on question number 31. I'm going to change the second one again. We're going to change that exponent. So we have 2.3 times 10 to the 4th minus, and I want this 3 to go up to a 4, so I move my decimal point 1 place to the left. So minus 0.20 times 10 to the 4th. Now I can just subtract 2.3 minus 0.2, and our answer, 2.1 times 10 to the 4th. If you're still having a little trouble with those, go back over your scientific notation notes, or go back and watch the scientific notation video again, and work through those practice problems one more time. Make sure you're taking notes on what you're doing in each individual step, and see if that helps as well. Now the next set of problems, I'm not going to write out the actual numbers for you, but I'm going to show you how to set up your problem. So in the first one, which is question number, pardon me while I fix that, question number 32, we have a distance, we have a speed, and we want to know how long. How long is a clue that you're looking for time. Now we haven't done our equations yet, but I will tell you that the equation for time, okay, t, or time, equals distance over speed. So you're going to divide. This is your distance, that goes on top, divided by your speed right here. Question number 34. You have a mass, you have dimensions, length, width, and height, and you need to find the density. Well, the question tells you right here that density is mass over volume. So, mass is this number here, so you would just rewrite that. And I will write out these so you can see how to fix the problem. 1.44 times 10 to the negative third kilogram. That's your mass. It's going to go over, you can see it's going to be a whole lot of stuff, our volume. Now you have a rectangle. The volume of a rectangle is going to be length times width times height. So you just put all of that on the bottom. Length 4.0 times 10 to the negative 2 meters times width 1.0 times 10 to the negative 2 meters times height 5.0 times 10 to the negative third meters. So you would multiply these three numbers first, take your mass divided by whatever you get here, your volume, and that will give you your density. Once again, make sure that your answer is written in scientific notation as well. One digit, that's not a zero, then a decimal point, and then all the rest of your numbers. And then your exponent should match. If you move your decimal point to correct your final answer, you have to change your exponent as well. The next set of problems, I'm going to do the same thing. I'm just going to show you how to set it up. You'll have to do the actual calculations, which you can do very simply with a calculator. In letter E here, we are converting 450 meters per second just into meters per hour. So that's a very, very simple conversion. We're going to make some train tracks. Make that one a little bit longer. And start with what we know. We know 450 meters for every 1 second. That's what we mean by meters per second. It means 450 meters in every 1 second. Now the meters are fine like that. You want to leave that meters alone because you're still looking to be in meters at the end. The seconds are what you want to do something about. So we're going to say, what's the next level up from seconds? So we can say minutes. So 60 seconds are in 1 minute. Now we can cancel our seconds. But we're not quite there yet because we want to be in hours. So how do we get from minutes to hours? Well, we say 60 minutes are in 1 hour. Now we can cancel our minutes. And we are left with meters per hour. So now you have to do the math and figure out the actual number. We're going to do pretty much exactly the same thing on this one here. It just has one more step to it. So let's draw our train track. Now in this case we know, I'm going to do this with blue, we know 3.3 kilometers for every 1 hour. We want to go to meters per second. So that means you're going to have to convert both units. You can start with whichever one you choose. I'm going to start with kilometers to meters. You could do it either way. Your answer should end up the same. So I go back to my metric stair-step chart, and I see that 1 kilometer or kilometer is 1,000 meters. Now I can cancel out kilometers, and I have the first part of my unit here. Now I want to go from hours to seconds. That's the opposite of what we just did. So I'll say 1 hour has 60 minutes. So I can cancel my hours. And I'll say 1 minute has 60 seconds. And I can cancel my minutes. So now you just do the math. You multiply across the top, divided by everything on the bottom. And finally, the carpeting questions. The first one is a little complicated, the second one is a little bit easier. So this says that you want to carpet your living room. It gives you the length and it gives you the width in feet and inches. But then the price is in square yards. So the first thing that you have to do is to convert feet and inches into yards. You're going to kind of go backwards a little bit. This is the easiest way to do that. And we're going to say 16 feet times 12 inches. Okay, so that'll give you a total number of inches plus 3.5 inches, because it tells you that there. You're going to take that whole number divided by 36 inches. There's 36 inches in a yard. So whatever you get for this is going to be your new length. You'll do the same thing for the second distance. So 14 feet times 12 inches plus 6.25 inches divided by 36 is going to give you some number of yards. That's your width. Then you have to do length times width. That's your area. Then times your dollar amount. It's a little bit complicated. Second one is a little bit easier. You have a room. You have a length. And you have a width. Area, length times width. Multiply these together and that gives you square meters. So length times width, right there and right there, times your dollar amount, which is right here. So you are going to have to do the math on your own. We'll be checking these in class tomorrow. I will be in for tutorials in the morning if you need help or if you just want to double check your answers. Good luck.